So the idea of this really it's a purpose-made knife forge, so it's fairly small. I have another big forge which is like over a metre long, double burner, which I plan to do soon, but this one is a dedicated knife forge, so it's fairly small. There's a few things that I think are a little bit different. The burner is full length, and it's a single row of jets. I'm trying to get an even heat. The problems I've seen using my other one, I'm trying to sort of overcome them sort of issues in a way. It's a fairly small diameter. This is drawn at 5 inches. I'm actually increasing it to 6 inches. So as I said, there will be a few little changes. And most of the time the door will probably stay shut because I'm making the exhaust vent, because you need an exhaust vent on a forge. I'm making that big enough to feed a knife in anyway. And the idea is to get a vortex effect on the inside of the forge, so the burner is set sort of high. So it's set up fairly high and we'll get a vortex effect. That's the theory anyway. This down here is the inline pump blower that I'm going to use. And then we've got the gas feed at the back, which will be, I think, will be slightly raised up, going in horizontally. But I've done a few tests before this on things like the shape of the manifold. It is slightly different to this one, the one I've finally gone with. But I've done a few different tests to get the most efficient, to get an even spread along the length of the manifold. So we'll crack on. I'm going to start by making the case, the stand, a few other bits, and then after that it's things like the door, cast the refractory, and I'm doing it slightly different to what I've seen before, and I've done sort of tests and it should work fine. So I'm starting off, I'm using a plasma cutter just to cut the main pieces for the body of the forge. I'm using, I think it's a 3mm, sort of 1/8 thick plate. I wouldn't normally sand it up like this, but this was powder coated. It was a piece I had in the workshop for ages. I thought I'll use it, so I've had to sand off the powder coating off both sides. You don't want to leave anything like that, especially where there's heat involved. It's just going to give off nasty smells and gases and things. So that's the 5 pieces for the body. But first thing I'll do is cut the slot for the ribbon burner. It's a lot easier to do when it's flat than when it's a box. So I've quickly just drawn out a few guidelines. So what I've done, this is the size of the interior of the forge. So then I've got a centre line going through, which will be the line of the burner. And so the actual block for the burner will be that width, and then it's going to be that length. So I'll now just do that cut out with the plasma. So I've cut the slot in the side panel, and I've also cut this plate. It will be a sort of flange plate for the manifold, the ribbon burner manifold. And I've drilled this, and I've also drilled through into the side of the forge body. So what I'll do now is weld captive nuts on the back, on the inside of the forge body panel. So when we come to bolt this on, it's really easy because it's already got the captive nuts inside. So I've welded the captive nuts inside for the manifold, and then I've just tacked the whole thing together, checked everything was square. These switchable magnets are good, 90 degree, just put them inside, switch them, and they'll just hold them at 90 degrees while you weld it together. So next is just to weld around the full thing. So I've also been cutting the parts. This is for the manifold, for the ribbon burner. So we've just plasma cut these, cleaned them up. We've just sort of bent this on the anvil, a little bit fiddly, but and it'll still need a few adjustments, but what I would do with something like this is just start tacking it round and then just adjusting the final parts. And then I've also cut done the cutout in the back plate for that as well. So these will all get welded together. So that's not going to take too long. And I've also cut, so while I was cutting, I've cut the piece for the door and formed the ring that'll strengthen that up. Again, I'll start tacking this and just tweaking this round as I go. So that'll give us the door. So that's the manifold all welded up. Also the door section, this will have the refractory cast into it, so we'll actually end up another inch thicker, and then there'll be the support for the hinge mechanism. I've also welded the stand. I did start off with a 2x1 box section, didn't like it, I cut it off, start again, and I put a heavier tube, just a little bit more stable, but also just seems to look right, and to me looking right is important. So the last thing I'm going to weld up is the tool rest, well, the workpiece rest, which is an adjustable sort of assembly. This is where it's handy to keep all them offcuts of little bits of offcut of steel. So I've got a tube that fits not too bad inside another one, which will be perfect for this. So this one welds onto the front leg, which gives us the adjustment in and out. This is then welded on there for the upright, and then we've got this one which will give us the height adjustment, and I'll have the rest welded on there. So that's how the whole thing sort of goes together. So that's the work rest weld in place. Not the tightest of welds on some of these, but hey. So this will have a nut welded on, so I can lock this in the position I want it. And the same with this arm as well. This slides in and out, and it'll have a nut welded on underneath, so I can lock that off. Right, so onto the ceramic blanket. We'll start cutting that. So I'm using a 50mm 2-inch ceramic blanket, and what I've done is cut just a square template, which is the size of the forge. And to start with, I'm just going to be cutting the squares. So I'm just using a sharp knife, old kitchen knife, which I tend to use for foam and things in the workshop, and just slice it. Cuts fairly easy with a sharp knife, and I'm pretty sure that you all know to sharpen a knife. This is going to get blunt because I'm cutting through to the aluminium, but we'll always resharpen it. Of all the knives in the workshop, this one, which is going to be the cheapest kitchen knife, gets the most use in this place because we do a lot of foam, and it just gets used for trimming. And then we also have this one, this Scuto type knife, flexible, which works well as well. Right, so we'll cut enough squares, because I'm doing this a little bit different to normal. Most people will wrap it round. So I'll probably take some stick for this one, and people will say, yeah, it ain't going to work and whatever. And there's also going to be a little bit of waste because I'm cutting out the circle and the area for the ribbon burner. But to me, this is just the easiest. I can get a nice solid job at the end of it, and it'll be stacked nice and tight, snug inside the forge. So I'll cut the rest of these, and then I'll do the template to cut the middles out. Right, so I've just jigsawed the template. I mean, normally with things like this, I use a CNC for loads of things, but what I'm trying to do with this project is is to sort of keep it with using simpler tools anyway, just so anybody can follow it. If I start using CNCs, 3D printers, which I would, then it's going to be more difficult for people to follow it. So that's the template, and this is where my other knife comes in. So it's just a matter of keeping the blade vertical. Watch your fingers underneath. Cuts surprisingly easy actually. It's a lot better than I thought it would be. So yes, you get this waste doing it this way. To me it's worth it because I'm going to get a better job at the end of it, and I won't throw them away. I'll bag them up, and you never know, I can always repurpose them another forge or something similar. One thing I do need to say is that please, when you're using this stuff, is wear gloves and wear a dust mask. I'm not wearing a dust mask today because I can't find one in the bloody workshop. So God knows where they are. I know we have some, but it's me taking the risk. But please, you guys don't take the risk with this. I think it's a lot worse once it's heated and the fibers start flowing. But even at this stage, I would, make sure you wear a glove and a respirator just to be safe. So that's all the cutouts done in them layers. What I've also done, I've split one of the squares sort of in half, and this will be the first piece that goes in the back of the forge. So the next thing is to start laying these in, but as I lay them in, what we're going to do is spray them with a rigidizer. So this one, I'm using all Vitcast products. So this one comes from them. I've just put some in the spray bottle, which we'll see how it goes with the spray bottle, but it's quite a thick sort of sticky solution, but if it doesn't work that way, then I can always use a brush or something else just to put on. But so we'll start laying these into the forge now. I'm going to sit the forge onto its back, and then just lay them all in and just sort of make sure they're all pushed to the outside. So I've got the first few layers in, so you can see what's happening. What I have done, which I'd forgot about earlier, I've just cut in the bottom layer. I've cut a square out, so that'll allow the refractory to go down to the base. Otherwise, that end, if you imagine the weight of the refractory, is not supported. It's sort of supported on the blanket, so at least that gives it down to the base, so it's got a solid support. So I'll continue right to the top, and I'm just going to stop sort of like an inch from the top, at which point I need to weld in some bits of rebar, and the rebar is really going to hold the front, which is going to be the sort of cast-in refractory as well. I mean, you're probably wondering what I'm going to do with the burner, but we'll come to that later. So that's all the layers in, and what I've left it's a little bit more than an inch from the top, because what the actual refractory will get cast up to there, it'll actually get past about an inch higher, so that gives me a good sort of solid sort of surface at the top there, which is going to add to the strength of it. So that's it for today. I've got to leave that at least overnight, but we'll check it tomorrow and see if it's not totally hard, or if it's still a little bit sticky, then I won't do the casting. But So the idea is now is this aluminium tube is what I'm using for my centre core to mould the refractory, and that just fits down the centre, and it leaves me a little bit less than an inch of castable refractory in there. So that's it for today, and we'll have a look at this tomorrow. So before I start the casting of the refractory, there's a few things to do. Firstly, I've cut the aperture in the door, but now what I'm going to do is what I want is the refractory to actually come through the door, sort of half an inch, and this isn't the actual opening because we're sort of coming in about 20 millimeters. So the opening is just this sort of size, which is big enough for most blades and sort of smaller Damascus billets. So I've used it's like a high density foam. You could use something like polystyrene, but I'm going to use this. Is ideal because I can hot glue it together, so it's fairly quick. So it's just going to build. I'm just going to glue these on. The idea with the hot glue, it'll come off nice and easy after, and the same with the foam. It's easy just to break it out really. So that's foam glued in place. So this part protruding through will be the aperture once it's actually cast. So what I need to do now is I want this to build up about 20 millimeters. So I need to build up the sides of that to the same height of this. So when I pour it, I get this refractory coming here. And the idea of doing this, it keeps the actual steel away from the heat in effect, and you've got this sort of barrier of refractory in between the steel and the sort of the inside of the forge. So that's that ready now. What I've done, I've used some PVC, well, I think it's ABS, and I actually just used some 3M VHB tape just to stick that on. And what I did, I set it that way just to make sure I get a nice straight line and an even height all the way around. So when I fill this with the refractory, it's just going to be flush right across the top. So it'll be fairly easy just to level that off, because this will be the face that goes up against the forge itself, so I want that as flat as possible. If it's not absolutely perfect, you can do a little bit of flattening after. I've done a few tests with that just to see how it works, and it works fine. Nearly forgot there. I'd forgotten to weld these supports in, and I've managed to get away with it without having to redo the plastic, so that's fine. What these will do is just help hold, once the refractory is cast, they'll just sort of help hold it in place, so the thing isn't going to drop out. And I have got a little lip under there as well, which it will sort of grab around as well, but this is just to make sure. Right, so this is the aluminium plug. This is going to go down the centre, and then it gets removed after. I've put a layer of thin plastic around it, so hopefully the aluminium will slide out and then the plastic will peel away. So what I've done with the main forge, added the rebar, which is going to, again, similar to the lid, the door, it's going to support the refractory after. I've done a raised side because that's the level I want the refractory to come to. I've boxed in the burner, so it actually, there's a recess of about an inch inside there, so that inch sort of block will come out into the burner manifold. So the first thing I will do is pour like an inch, around about an inch into the bottom of this. That will be the back of the forge. Then I'm going to put the aluminium plug in, and then we'll pour the refractory.
So it looks fairly dry when it's going in, but as it goes in, the water comes to the top, it does settle down nicely. What I'm trying to do is just keep it centered as it moves up, which that's within a mil or so, but because of the vibration it's actually still quite easy to move this. So I'm about halfway. Don't think I'm going to have quite enough in this bucket. Well, no, I won't. I'll have to mix some more, but so I'll use this up, just make sure it's back. I could glue some braces across, but I think it's fairly straightforward this way, just keeping a check on it. Right, so that's all the refractory poured. A few little bubbles, nothing to worry about. The important thing is getting that as flat as possible because the door is going to seat against it. Once it's done, I can sort of sand it with a block just to get it perfect if I need, but it should be fine. So that's taken about 40 to 45 kilos of refractory, more than I thought, but I had plenty anyway. And it's not too, I think I probably rushed a little bit, but it's not too bad a job to do. So I'll leave that 24 hours at least before I take the tube out and take this off. Then it will start to dry a little bit better and cure, and then I'm going to probably leave it like a week before I start to fire it. And even when I do fire it, it's short bursts, just build up the temperature. So we'll see how we go. Hopefully these come out okay. That should be fun.